Hello, and welcome to the Modern Analytics Academy. My name is Chris Mitchell. I'm a cloud solution architect with Microsoft's Global Partner Solutions team, and today I'll be taking you through the overview session. So for our agenda today, we're going to spend a little bit of time introducing you to the team. We're going to go over the various sessions that make up the Modern Analytics Academy, and then we're going to dig into our content, which is going to comprise of some trends that we see that are driving innovation in the analytics space. We'll walk through Microsoft solutions that address this, and then we'll pop into a quick demo kind of highlighting some of the technologies that are involved. So here are the members of the team. We're all cloud solution architects on the Global Partner Solutions team, and we all collectively work on the analytics solutions with our partners. Each one of us is going to be taking a different aspect of a modern analytics architecture and digging into it in a little detail. So obviously this session is more of an overview session, so we're not going to go deep into anything, but the subsequent sessions will dissect a modern analytics solution and go in deeper. And so what does that look like? So we've decided to break this up across a variety of areas. First of all, data acquisition and storage. When we look at data acquisition and storage, we're going to be spending some time looking at the nuances of how the various source systems where your data may come from work, and looking at some of the nuances about how those systems influence how you acquire the data and then store it. In data modeling, we'll spend some time looking at how do you take that data that you've acquired, structure it in some sort of a logical way, and store it and prepare it for the purposes of usage downstream in reporting applications and other things. In data pipelines, we'll be looking more at less about the function for how you store the data and more about how you move that data through a data engineering process that takes the data in its raw format and prepares it for that downstream consumption. In the data security and governance section, we'll start looking at how do you put a governance platform on top of that data engineering process that you've created and use it to do things like control the security of who has access to the data, making sure that the data is discoverable, and also doing things like applying compliance policies to the data and viewing lineage of the data the transformations that data has gone through in your process. And then finally, in the data visualization, this is all about reporting. So how do the downstream users of the data connect to and consume that data and get timely business value out of that data? So let's jump in here and look at some industry trends. So what we are seeing is that many industries are in the midst of what we would call this digital transformation. Now, this has been going on for a while, but the data that they're using, or they're starting to look at their data in a new way. They're starting to look at their data as now a valuable business asset, and they're beginning to take this data, not only look for new sources of data, but look at how they can use this data that they already have, and how do they use the combination of this new data that they're acquiring, in addition to the data that they already have, to make better informed business decisions and potentially, get a competitive edge. In essence, what we've seen is that businesses are becoming much more data hungry than they used to be. Now they're looking to technology to figure out how they can, wrangle this data and get value out of that data. And specifically, how do they do it in the much larger volumes of data that we're seeing today? Obviously, this slide covers a few examples of how some industries are changing that is causing some of this explosion in data, but there's countless examples of it. And so these are just a few that we think are interesting. So what's interesting, though, is even with this landscape of data evolution and businesses looking to acquire new value out of their data, the excitement and the investment and the enthusiasm, businesses are still struggling with data. The increased focus in many ways has magnified existing problems that they have with their data. And even though the analytics and AI is a number one investment area of these businesses, the return on investment that they're seeing isn't necessarily there because of these inherent challenges that they have in dealing with their data. So let's look at some of what might contribute to that. So this is probably a set of phraseology that's maybe a little bit overused when it comes to the big data space. But it's important to look at, we're looking at that landscape of digital transformation. We're looking at how all this data is coming in. That's largely what's contributing to this explosion of data. And this explosion of data in these 3 V's that we use often, the volume, variety, and velocity of data, what it's really doing is this explosion of data has caused businesses to rethink the way that they traditionally approach data. So that traditional data warehouse implementation often focused on some sort of a batch-oriented, repeatable, consistent way for acquiring the data, and many times was using really specialized hardware and storing that data in a way that you had to be somewhat brutal about making sure that you only stored the data that you needed in order to answer your business questions, right? And so because of that, these processes were, very traditional waterfall-oriented processes where you'd go from requirements to reporting solution, and that the time to go through that life cycle could be measured in weeks or months. And that really negatively impacted the agility of a business in order to garner value out of the data. Oftentimes, they couldn't get from question to answer quick enough. And so this is where the world of big data enters, right? We try to flip that data problem on its head, and we start looking at, well, how do we, instead of trying to figure out what data do we keep, instead we start thinking about what data do we throw away? And oftentimes the answer is nothing, right? And big data architectures were exceptionally good at dealing with these V's, dealing with large volumes of data that is in often very poorly structured or lightly structured format, and dealing with it at the speed that we're dealing with now. So, kind of coming out of this new way of thinking about data is where a lot of the projects that make up the Hadoop ecosystem come from, right? They were often chosen for these workloads because they were much more agile at dealing with acquiring data, storing data, and giving users access to that data. And then that ecosystem evolved to include technologies like Spark and or SaaS platforms like Databricks to enable faster consumption and usage of that data. The problem is that even though technology was really clever at how to take advantage of this data, businesses were gaining value out of these solutions to big data problems. They still have this inherent burden in the approach because the existing data solutions are still in place. So now we kind of find ourselves in this world where we've got 2 analytics solutions. We've got kind of the traditional ecosystem where data warehouse exists, and because now we have these 2 ecosystems, they're often owned by 2 different teams. They often use totally different underlying technologies. They often have different security mechanisms, and the sets of data might not necessarily agree with each other all the time. And so because of this, it creates large integration problems between the technologies of the 2 ecosystems and the teams that are working on them. So in this world of multiple analytics technologies, solving these different niches, what we really need to look for is there a way to better integrate, better manage, while still gaining the inherent value of the underlying technologies between these 2 approaches, right? How do we get the value of the fast, agile experimentation of exploration that a big data architecture gives us, but we get the proven reliability, consistency of a relational data warehouse? And this is really where Synapse comes in, right? While this may sound like a, kind of catchy marketing, Synapse is the solution to everything, Synapse is really designed from the ground up to be this single service that brings these 2 worlds together. So while Synapse has both big data features and it also has data warehousing features, the point here is that Synapse works with an integrated underlying storage platform. It works with a single security model that's all built on top of the robust Azure Active Directory infrastructure. Multiple compute models can be put in front of this storage. So we can use more of the big data Spark style of consumption, or we can also use something that's a traditional, more of a relational database oriented technology in front of it as well. And so because of this shared storage, shared security infrastructure, but with multiple compute models, it gives us this great ability to switch back and forth between the two where necessary, but all in this integrated single platform with a single data engineering environment that allows you to orchestrate these processes across these multiple compute models. So no longer are you really limited by the integration points between these two technologies. So obviously, there's more to a modern analytics solution than just Synapse. We wanted to give you a little of a glimpse what a modern analytics solution might look like when it's realized. And so I want to dissect this a little bit and walk through the various areas. So obviously on the left here you have a variety of different things that kind of suggest that that data is coming from a variety of different places, which we all know it is. Back in the day, you might have a couple line of business systems that you would pull data from. You might have your ERP system and and some sort of inventory system and some sort of sales system pull data together. But obviously, those data sources have exploded. Now we need to be able to connect to data in a variety of different mechanisms, right? This data could be coming from, some sort of an on-premises line of business system, but it could also be coming from some sort of a cloud-hosted software as a service platform that no longer communicates via, database connections. It communicates via, REST APIs. You might find that you're acquiring data from some sort of a social network, and so you might even have an IoT-based solution that's, giving you a stream of sensor data. And so all of these different pieces of data are all relevant to your modern analytics solution. And what we need to be able to do is we need to use technologies to connect to these variety of different systems and acquire that data. So that's really what this ingestion phase is all about, is how do we connect to these disparate systems that live across a mixture of the cloud and on-premises and connect to that data. When we store data, obviously storage needs to be highly scalable. Since we're dealing with explosion of data, it's absolutely critical that this data is not only scalable, but it's also resilient. And so while data lakes now make this possible to store theoretically limitless amounts of data, it's less about deciding what you want to keep, and it's more about, like I said before, deciding what you want to throw away. And oftentimes you throw away nothing. So now that we've acquired all this data, when we look at exploration, right, we really need to be able to rationalize over that data now that we're storing in the data lake and quickly do data exploration and query. And that's what this Explorer area is all about. It's how do we, do ad hoc query over something like a storage location full of JSON files and actually write real queries against it to see what's in the data, explore it, examine it, and figure out how we want to use that data. Prep and train is obviously all about taking that, like I said, that semi-structured. Maybe you've got JSON data, maybe you've got CSV files, it could be images. Prep and train is about how do you go against that data and then shape it and transform it into something that is usable for downstream query tools, right? Which really prefer more of, tabular-oriented data. So how do you take that semi-structured and unstructured data and turn it into something tabular and usable? And potentially here in that prep and train stage as well, we may be pulling in some things like machine learning and artificial intelligence. We might call out to a service that lets us detect sentiment, or we might do some, classification, or we might do some things for like anomaly detection. All those things can really happen in this prep and train phase. And then model and serve. This is really kind of the last view of the data. You're going through a series of refinements. Model and serve is about making sure users have timely access to the data. How do they connect to that data? How do they consume it in an ad hoc way? How do they use reporting tools in front of that data? We have to service the data to users to get business value out of it. Otherwise, all this other work is for naught. And then finally, metadata management and governance. So obviously with all this data that we've acquired, we've got security and regulatory concerns. Which users are allowed to see which data? These haven't gone away, right? And in many ways, we've made the data more discoverable. So how do we make sure that we make the data discoverable, but we also make sure that it's secure and compliant and trusted? And governance tools really help us with that. So that's a quick view of what a modern analytics architecture might look like in Azure. And we already had, and while you may think about this, you realize we already had a lot of these capabilities across a variety of different tools inside of Azure. We may have looked at things like, Azure Data Factory and SQL Data Warehouse. But what we've really focused on with Synapse is how do these technologies play together, right? So it's less about a smattering of products that have loose integration. It's more about this integrated experience that brings all of these challenges that you deal with in a modern analytics solution together in one place, right? And that's really what we look at when we built this platform. And so here's a number of areas that were focus areas for Synapse when we created it. But I think what is more important is, up until this point, we've mainly talked about Synapse. But I personally really like to think of Synapse as the center of the universe, right? Synapse isn't the only part of a modern analytics solution. When I was talking previously, I talked about data governance, right? Data governance is a feature that's offered by Purview. There's other technologies like Power BI and Azure Machine Learning that nicely integrate with Azure Synapse Analytics and really round out this platform. So let's take a deeper look. So Azure Purview, let's spend a little bit of time here. So we mentioned earlier that metadata management and governance is really this key component of a complete analytics solution. So Purview is a new offering in Azure that's really designed to address the unique challenges of the hybrid data world we live in. Being able to give us the ability to build a governance platform that spans multiple clouds and also spans hybrid on-premises cloud offerings. So the components that really make up Purview are all about maximizing, the business value of data. So in addition to just storing the data, how do we catalog the data? Apply some sort of a business glossary to that data, make it searchable and discoverable, and then also help people gain value and trust in that data through things like data lineage. So if you're looking at a data source and you see a number, how do you gain trust in the fact that that number is accurate? Seeing the steps and the stages it went through in order to get where it is a very key part of that data lineage. And then data insights also is a whole bunch of reports that come along with the Purview platform that give you insights into the data, how fresh it is, where did it come from, etc. Another important thing to look at here is how the technologies work together. So we really talked about Synapse. Well, if we look at the combination of Purview plus Synapse and plus Power BI, which we haven't talked about yet, how do we leverage the Purview platform to get more value out of these two other technologies? So we really look at this across these three pillars of discover, browse and search, and then the enhanced metadata, right? And so when you look here at the discovery phase, this is wiring Synapse up to your Synapse or your Power BI environments. Now Purview has the ability to crawl those environments. You register Purview with a Synapse workspace, or you register Power BI, or register Purview with your Power BI tenant or workspace, and now these assets get surfaced in the catalog for Purview. So now Purview, you can use Purview to search the catalog and discover assets that you might not have been aware of. So browse and search, obviously, the discovery phase is all about the crawling and figuring out what's out there. The browse and search is something that's surfaced by Purview so that users can go in and search for data sets in Purview from linked workspaces, find Power BI dashboards and reports that they might not have known about, right? And then finally, the enhanced metadata, right? This is where not only does Purview just discover the data sets and make them searchable, Purview is also being able to do things like pour through the internals of those data sets and models and understand not only what data do they surface, but where does the data come from? What transformations does it come from? And then do things like apply policy to say, oh, wow, this report needs a higher sensitivity level because it's got a social security number in it. Being able to take that policy information and use that to govern the data and address sensitivity labels, etc. So that's a big part of the Purview platform, is adding that governance layer to the existing data assets that you have, both in Synapse and Purview, but also outside of those Azure native properties as well. So Azure Machine Learning. Azure Machine Learning, as I mentioned before, is something that often falls into that kind of prep and train phase. So Azure Machine Learning is a rich tool set that we have that's available to us that is really designed, as we say, to democratize that predictive power, right? So your data engineers and your data scientists are able to collaborate seamlessly across your data. And they have a bunch of different modalities based on, a combination of speed, preference, etc. And so Azure Machine Learning surfaces in both Power BI and in Synapse via a couple of ways. So for example, we have technologies like auto machine learning that you can point at a data set and let it automatically train a machine learning model. You give it some guardrails about how long you want it to spend training and what things you want it to optimize for, and it will automatically build a model for you behind the scenes. So that's obviously that low code, no code style. We also have the ability to leverage things like pre-built models. So we'll have some really common pre-built models like anomaly detection and sentiment analysis. And all of these things wired directly into Power BI and Synapse in a really easy, seamless way to make it really easy to add that to part of your data engineering process. For the more sophisticated models, we have the ability to publish those models in a way that can also be consumed in a very lightweight way inside of Synapse as well. But the key point here is that while Synapse is really focused on the data engineering pipeline, it's really easy to integrate artificial intelligence and machine learning capabilities into those data pipelines. And then we'd be remiss if we didn't talk about the combination of Power BI and Synapse, right? So if Power BI is the visualization tool, Synapse is the engine that's behind it, right? And so with the combination of Power BI and Synapse together, Power BI brings us all the agile, easy to build reporting features, but it's also got a lot of really great features that allow us to build these complex models that have the ability to kind of take the reports beyond this simple departmental tool and move them into a broader, more robust big data reporting solution, leveraging the power of the Synapse engine behind these Power BI reports allows us to give business users the ability to deal with these ever-increasing volumes of data and easy ways to query across these large volumes of data to derive value. So Power BI and Synapse are working in concert to solve this big data problem by playing to each other's strengths. So users are able to get really fast, high-level aggregate view of the data, but then as they see something that needs their attention, they have the ability to drill down into the granular level as well. And being able to transition from that aggregate to granular in a really seamless way with hiding that complexity from the end user is a really powerful feature of Power BI and Synapse working together. And so obviously we've seen great success with the combination of Power BI and Synapse. Using the two of these together really is helping our customers, maximize maximize the return on investment they're getting, and getting faster time to insights, and really overall having a lower total cost of ownership of their complete analytics solution. Okay, so to illustrate these concepts, let's jump into a demo to look at how we might use this in the real world. So for our purposes here, we're going to be leveraging Twitter. The Twitter scenario that we've got here is around following a specific hashtag. So what we've done is we've put together a solution that monitors the specific hashtag and then drives data coming from Twitter through an end-to-end data pipeline all the way from data acquisition to data visualization. And this is a really interesting problem to us because we're seeing lots and lots and lots of businesses dealing with fairly large amounts of JSON data. And so if you look at what might be happening on the left, these are the types of things that the users of Twitter are doing. They're posting something, they put some commentary in there, it happens at a specific date, it might have some retweets or some likes and so forth, and might have a hashtag, maybe it has an image to go along with it. But bottom line is this tweet, semi-structured in nature. But from our perspective, what it looks like is this JSON payload. The JSON payload is going to have the body, like we said. It's going to have some things like hashtags and mentions and things like that, in addition to the timestamp and so forth. And so what we want to do is acquire this data. So to achieve this, we built this architecture that does this. And so you could see earlier we talked about the ingest, the store, the transform, prepare architecture elements. If you look here on the left, this is the phase where we're acquiring this data. We're connecting to the Twitter API and pushing that data into Cosmos DB. We're leveraging a feature of Cosmos DB called Synapse Link that makes that data available to the Synapse Spark pool for querying. And we're using a number of steps here inside the Synapse environment to do some things to transform and prepare the data, to model and serve that data, ultimately to Power BI. So let's pop over to the Azure portal and look at Synapse. All right, so when I land here in the Synapse homepage, the Synapse homepage is going to bring me here. It's going to give me some pointers to some of the common problems that we face in an analytics solution like ingest, explore, and visualize. But the area where we want to start today here is in the Data Hub. Now the Data Hub is going to have two elements to it. When you provision an environment in Synapse, it's going to by default have a workspace pool that is a serverless SQL pool. That serverless SQL pool is kind of interesting because it's not running. It's something that it only charges you for the compute as you execute queries against it. And so we start with one of those by default. And if you look at our default database that we have here for our Twitter data environment, you can see that there's a number of areas here we can navigate this like a database that's got a number of objects and things in it. Now what's interesting about this is the tables all show up here as external tables. And the reason this is important is because there's no attached storage to this database. All this data is actually being stored in the underlying data lake. So all the external tables here, in fact, don't exist. We could have persisted some, but for our purposes, all of our data is actually coming from a series of views that we'll get into and explore in a little bit. We also have in the Data Hub the notion of linked services. So this is where you can attach to other things. So the data lake storage that we have here is going to show up like a linked service, and we'll spend some time exploring this later, but you can see one of the areas down in my underlying storage has got some data in it. I also have our Cosmos DB environment. So remember when we looked at the architecture, we looked at the fact that we're using a feature of Cosmos DB and Synapse called Synapse Link that effectively takes the change feed of what's happening inside of Cosmos DB and makes it visible to Synapse Link. So this is a great easy button to make that stream of JSON data that is coming into Cosmos DB available to us. Now, Cosmos DB is a transactional NoSQL database that runs in the cloud. So Cosmos DB is the area where all of those tweets are landing, and then Synapse Link is keeping the data lake up to date with all those tweets for us. And so this shows up where our tweet data is. The tweet data is the collection inside of Cosmos DB where our tweets are landing. And so Synapse makes it really easy for us to start consuming this data, because I can do things like right-click and say New SQL Script, top 10 rows. And it pre-builds this query for me that gives me the ability to set up the identity, so we can use a managed identity and store it securely. I've already done this, so I can go straight to the query, execute this query, and what's going on behind the scenes is this is opening a connection to that Synapse store, validating, it's going to use the credential that I created, it's going to query the tweet data, and it's going to pull that in. Now, the data that's coming in is all JSON data. So when it shows up here for us, you can see that the data is, fairly ugly. It's got some elements that are about it that are specific to, the tweet ID and the timestamp and the like. But the data that we really care about here is this original tweet data. And the original tweet data is this big JSON payload. So when we look at this JSON payload, obviously the JSON payload, we can do a little bit more with that. Now, the other thing that's interesting about this Cosmos DB environment that I didn't mention before is we also have the right-click for a new SQL script. One of the other things that we can do is say right-click new notebook. And this new notebook, load to data frame, create Spark table and so forth. It gives us a lot of really great accelerators for doing some of those initial data engineering steps. So for example, if I said load to data frame, it would go ahead and create a new notebook with built-in Spark. I would just attach it to the appropriate Spark pool that I have, and now it's setting up the data frame to start that data engineering process that we might go through. Now, another thing that we have available to us now that we've got this tweet and we have queries that we can run across these tweets, if we go over here to the Develop Hub, this is where you can begin doing things like writing queries against the data and building notebooks against the data. So if I come in here and look at Create Cosmos View, you can see we've got the standard create view syntax here. And notice this query here, select star from, is almost identical to the query that I had here originally, except I've taken off the top on it. So this is a way now that I can create that view that shows up in my serverless SQL database and start doing things like querying against this view. Now, in addition to this, the open row set schema only gives me so much because it's giving me that ugly, JSON data. However, if we move forward in our data engineering process, you can see now I'm in a notebook that has doing a bunch of steps in order to prepare my data for further downstream consumption. And this is where you would do things like set parameters for your data execution. Again, we're connecting to that tweet data. We're beginning to do some additional decoration of that tweet data by adding additional columns, and even running specific queries against that tweet data in order to do some additional transformation and flattening of that data. And then ultimately, further down here, we're even calling out to some Azure Cognitive Services to do things like conform the sentiment and do translations of the text in case we're getting translations in different languages. And even in this case, we're doing some things like clearing out the profanity so we don't have salty language in our end solution. And then ultimately, all this data then gets persisted down into the data lake as Parquet data. So going through this process takes that data, goes through some refinements to not only process the structure of the data, which we mentioned was that JSON data, and also goes out and calls out to the model, doing some additional modeling by augmenting that data and adding additional value to that data that comes from those cognitive services and so forth. So if we pop back over and look at the data lake, the end result of this execution of going through these multiple stages of that data transformation is that we end up with a structure here in our data lake that's underneath this data warehouse called table tweets. And this table tweets, it's stored in a Parquet format. If you're not familiar with Parquet, it's a highly optimized file storage mechanism that's often used in big data solutions that's specifically targeted for being really tiny on disk so that it can be read really quickly. And there's a number of other aspects to it as well that deal with partitioning and the like. But you can see here I've got these files underneath of my data lake, and if I come here and right click on this and say new SQL script again, I'm navigating now down to my data lake, and I'm able to use that same thing of select top 100 rows or run a notebook against it. In this particular case, I'll select top 100 rows, and I think one of the things you'll notice really quickly is how much faster we actually get that first 100 rows. Where I ran off the first 100 rows that came off of Cosmos DB, it was 15-ish seconds. Now I'm running it, and it's happening in a couple of seconds. Which is really great. And you can see now as well that we've applied some structure to that data. So we can see, a normalized time column for it. The columns that, were buried down into that JSON structure now have been promoted to real top-level columns in the data set. So we can see who it was tweeted by, what the tweet text. And you can even see the outcome of calling out to our cognitive services. You can see we've assigned a sentiment to this particular tweet and even did some translation. And I'm not going to tempt fate by digging down in and looking for one that's got translation in it just for fear of showing some bad language. But the point here is that we've captured the original tweet text, but then we've also done some sanitization of that tweet in order to make it a little bit more friendly for average user consumption. And so all this has been managed via that data engineering process. So far we've connected to the Cosmos DB via that Synapse link. We've gone through some stages of data engineering by querying that data, flattening the data, calling out to some cognitive services in order to augment that data. But one of the other things that we need to think about as part of this data is the data pipeline phase of this, right? So how do we make that a repeatable process? So since we've built all of this inside this notion of a notebook, all this logic is encapsulated in this single notebook. We need to go down to the next area of our data, of our Synapse Studio, and flip over here to the integration area. So the integration area is where you build and schedule pipelines. So pipelines can be really sophisticated, a number of steps that takes data through a series of stages. In our particular case, our data pipeline is actually pretty straightforward because a lot of that logic is baked into that one notebook. And so you can see here what we've done is we've created this merge tweets pipeline. The merge tweets pipeline executes this notebook, and at this top level you can see we've got start date and an end date. So what we've done is we've created the schedule that gives a start date and an end date, and limits the top number of rows so we can run this in kind of small batches. And what this is doing is, on a schedule, we can kick off the schedule. The schedule define the start date and the end date, kick this off, and process that batch of rows. And so we can schedule that as often as we'd like. But if you look here, if we go into triggers, we can do a trigger now to just kick it off manually, or we can pick an existing schedule. So you can see right now we have a daily load schedule set up. We could do this, more frequently if we wanted, every 5 minutes, every 5 hours, or whatever. And that would give us the ability to execute this on that schedule and keep that data lake and our Synapse environment as fresh as possible. And so all this is that kind of end-to-end story, how we're moving back and forth between this notion of files, SQL queries, Spark notebooks, services APIs to do the machine learning execution, and then ultimately scheduling that pipeline to make that data visible. With all that, the next piece to look at is that end stream consumption. So the Synapse environment gives us a SQL database. And as we mentioned previously, Power BI is this great way to visualize data. So Power BI, we can take the Power BI desktop client or powerbi.com and we can connect to this data set and build all sorts of really rich and compelling visualizations on that. But Power BI actually lands right inside the Synapse workspace as well. If we flip over to the Develop tab where we were at before, you can see down here I've got a Power BI section. So what we've done is we've actually linked in a series of reports directly into this Synapse environment so that our developers can not only build the data engineering pipeline, but they can also see the results of those efforts by digging in and looking at reports. And in this particular scenario, we could see the count of tweets and their sentiment over time by certain people that we're looking at that are mentioned in the tweets. We can see the overall tweet mix, and we can even do things like drill into the tweets about a specific person on a specific day. For example, we'll go look at Claire and we'll say, hey, let me see the positive tweets on this particular day, and drill into the details, and we can actually even see the details of the individual tweets that happen on that day. And so we're moving from this kind of aggregate view that gives us a high-level view of it down into the individual row-level detail, and making that visible to our users. And I don't want to stay on this view very long because there's a possibility that there's some salty language out here. So with that, that kind of shows the end-to-end experience with the Power BI integration. The last thing to point out here is that we have the ability to, inside this environment, link also to our Azure Purview environment. So you can see here down here, I've linked the Azure Purview environment to the Synapse workspace, and it's showing up as connected. So I could pop over here to Purview, and I can see now that in my Purview environment, I've got Azure Synapse Analytics as a source that is managed and monitored. And what it would do is it would go through and connect to Synapse and enumerate the content that's out there on a schedule and do things to me like expose the data assets that are under management in that and apply any policy that I've defined as well. So with that, you can see that we've gone through all these steps in it. We've gone through the acquisition of the data, we've gone through the transformation and modeling of the data, and then ultimately the visualization of the data, and then with the added bonus of also including some things to show you how that data could be governed via Purview. So with that, that was everything we had to show you today. I want to remind everyone that aka.ms/MAA for Modern Analytics Academy is live, and if you go out there, you will find an environment that shows you, kind of some overview of the Modern Analytics Academy. Out here, you're going to find the top level content that has got the overview of all the different sessions that we're listing and the topics that we cover under each one of these sessions. And there's going to be subsequent links that are going to be coming that are going to dig into even hands-on learning that you can do. So after you've reviewed the session, if you want to get some hands-on experience with this content, there'll be links to a bunch of hands-on resources like quick starts and hands-on labs that you can go to as well. Thanks for joining us today. We hope you found this useful, and we look forward to seeing you in our future sessions.